Hey everybody, in this video we're going to create a working alarm clock that plays music using Java. Alright, let's get started everybody. This alarm clock is going to serve as a final project for us. We'll combine a lot of concepts that we've learned throughout the series. When starting a new project, a good first step is to declare all your variables, or other objects that you'll need throughout this program. We'll begin with the scanner because we'll be accepting user input. A user is going to enter in a time. Scanner equals new scanner, pass in System.in, and we'll be importing classes as we go along. At the end of this program, we're going to close our scanner, but we'll actually move it later on, because our alarm clock class is actually going to be using it. More on that later. We have our scanner, and currently we're closing it. A user is going to use the scanner and enter in hours, minutes, and seconds to set the alarm. When the user types in a string representation of a time, we need to parse it into a LocalTime object, but we'll need a formatter object. We will create a DateTimeFormatter object. You'll need to import this class too. We'll name this object formatter equals, we will access the class of DateTimeFormatter, call the of_pattern method. Within this method, we have to pass in a pattern that represents the time. For hours, minutes, and seconds, within a string, we will pass in 2 capital H's for hours, colon, 2 lowercase m's for minutes, colon, 2 lowercase s's for seconds. When a user types in a string representation of a time using our scanner, we'll use this formatter object when we parse it into a time object. Then we will create a local time object, which we will name alarmTime. We'll instantiate that later. Import this class. Now we'll need a user to enter in the time. We'll create a prompt. Enter an alarm time. We'll give them a prompt for this format: hours, minutes, seconds. Let me switch this to print, because I like it on the same line. Let's create a string variable of, let's name this inputTime, equals, use our scanner, call the nextLine method to get a line of text from the user. Alright, now here's where we're going to parse our string, our input time, and assign it to our alarmTime object. So we have to convert it, we have to parse it. We will assign our alarmTime object, set it equal to, access the class of LocalTime, and there is a parse method. We have to pass in 2 arguments. The first is a string representation of our time, and our formatter object that we have previously declared and instantiated. Then we'll output the following message: alarm set for plus our alarm time. We can output it directly. Let's do a test run. Let's say I set my alarm for 7:30. This is going to be in military time. Alarm set for 7:30. What if we type in a time that doesn't make sense? Like the word pizza. Well, we encounter an exception, a DateTimeParseException. We can use exception handling to catch this exception. I'm just going to copy it, and then paste it later. This portion is considered dangerous code. We can put that within a try block. Try this dangerous code, catch any of the following exceptions. We will catch that DateTimeParseException, which we will name E. Import this class. Okay, then take all of this previous code, stick it within our try block. We will try this code and catch this exception if it pops up. We'll output the following. Let's say invalid format. Please use hours, minutes, seconds. Let me change that to use. I've already used pizza. Let's go with taco for the alarm time. Invalid format, please use hours, minutes, seconds. Let's try 8 o'clock. Alarm set for 8 o'clock. Alright, good. We know that that works. Why don't we prompt the user to enter in the time again if it is an invalid format? We can use a while loop. While some condition is true, continue to do the following. Let's cut our code, our try and catch blocks, stick it within the while loop. What's our condition? While our alarm time is empty. There's actually a value that you can assign an object, and that is null. Null has no value. Within our while loop, we'll continue this while loop while our alarm time is equal to a value of null. So if I were to just hit enter, we get an invalid format. Please use hours, minutes, seconds. And it won't let me continue until I enter in a valid time. So I will set this to be 9 o'clock. And then our alarm is set for 9 o'clock. The first section of this project is complete. We have successfully set an alarm time. Our alarm time is a local time object. The next part is to create an alarm clock class to create alarm clock objects. We're going to create an alarm clock class. File, new, Java class. We will name this class alarm clock. We're going to have our alarm clock run on a separate thread. To do that, we can implement the runnable interface. So we can do some threading. But if we implement the runnable interface, it's kind of like we're signing a contract. We have to override the run method, public void run. When this alarm clock is running on a separate thread, it's going to execute any code within the run method, but we're going to fill that in later. Currently, our alarm clock needs one thing. It needs an alarm time, which we will send it from the main Java file. Let's set that up as a field. With our alarm time, I'm going to make it private. I only want the alarm clock class to be able to change it. I will also make it final. It's unchangeable. The data type, it's an object. It's a local time object, which we will name alarmTime. And then we do need to import this class too. Alright, then we need a constructor. We will take our alarm clock. We need one parameter currently. A local time of alarm time. We will assign this dot alarm time equals the alarm time that we receive. Alright, that's good. Okay, let's go back to our main Java file. Before we close our scanner, we're going to create an alarm clock object. Alarm clock is the class. We will name this object alarm clock equals new alarm clock. But the way that we set up this class is that we have to pass in an alarm time, a local time object. We have our alarm time. We've already verified it using this while loop. It should be a valid format. We will pass in our local time of alarm time to the alarm clock in order to construct it. Since our alarm clock is going to be running on a separate thread, we'll have to create a new thread. Thread, let's name this alarm thread, equals a new thread. And then we'll pass in our alarm clock. We can do this because our alarm clock, it implements the runnable interface. So our alarm clock is going to run on a different thread than the main thread. To start a thread, you will take your thread, in this case alarm thread, call the start method. So once we start our alarm thread, it's going to execute the run method. Alright, so for testing purposes, let's get the time right now. To get the time right now, we will create a local time object. Let's just call it now. What's the time right now? Equals access the class of local time, call the now method. I will display the time right now, just for testing purposes. I want to be sure that our alarm clock class is working. So we have to enter in a valid alarm time. I'll just set it to be 8 a.m. Alarm is set, and here's the current time right now, at least for me. I'm filming this video at 7:26 in the morning. It is going to be in military time. And then we have a bunch of milliseconds after. We know that we're successfully calling the run method. So we have the time right now. We're going to compare times. Is the time right now before our alarm time? If it is, we'll continue sleeping. We'll have our thread sleep. We can delete this print statement. I was just testing it. We need to check if the time right now is before the alarm time. If it is, we'll continue waiting. We can do this with the while loop. Take our time right now, call the isBefore method. We can compare local times. Is the time right now before our alarm time? If it is, we're going to sleep for 1 second. Access the thread class, sleep for 1000 milliseconds. All right, we do need to surround this with a try and catch block. Let's do that. Try and sleep for 1000 milliseconds. If this thread is interrupted, we'll output the following. Thread was interrupted. This is if we encounter an interrupted exception. We're checking the time right now. Is it before our alarm time? If it is, let's output the time currently. I'm going to condense some of this code. Outside of our while loop, we're already creating an object of now. So why don't we do this? Let's cut this line and do the following. Access the class of LocalTime. Call the now method. And then method chain the isBefore method. Basically, every second, we're going to get the time right now and compare it to our alarm time. Is the time right now before our alarm time? If this while loop is running, we'll output the time. So we'll output LocalTime, call the now method. Let's do a test run. Enter an alarm time. I'll just say 8 a.m. to keep it simple. Alarm set for 8 a.m. And here's the current time. It updates every 1 second, approximately every 1 second. Now let's do some formatting, because I don't like all these milliseconds afterwards. Here's what we could do. We could create an integer variable of hours, set it equal to, access the class of LocalTime, call the now method, then method chain the getHour method to return the number of hours. Then we're going to do this with minutes. Int minutes get minute. Int seconds get second. Okay, I'm going to show you what happens if I print hours plus a colon plus minutes plus a colon again plus seconds. Here's what we have currently. I will set this to be 8 a.m. Alarm set for 8 a.m. So this looks pretty good, but I would like some leading zeros. We could do that with printf. So let's switch this around. Printf. For printf, we'll add some placeholders, which we can use with a %sign. To display 2 leading zeros, we can use 0, 2. If we're going to insert an integer, we have to use d for decimal. So let's do this 3 times. 0 to d, %0 to d. We are inserting hours, minutes, and seconds. Let's try it again. I will set the time to be 8 a.m. Oh, and then I'm forgetting the colons and a new line character. So let's insert some colons and then add a new line character to the end because I forgot to do that. That's much better. And we have that leading 0 if one of these values is 1 digit. That looks pretty good. Now what we'll do, rather than updating the time and placing it on a new line every 1000 milliseconds, we're going to edit it in place. Here's how. With our printf statement, we're going to insert \r. This is for carriage return. It'll move the cursor back to the beginning, and then we'll get rid of the new line character. It should look something like this now. Our time is going to update in place rather than take up a new line for each time it updates. I think this looks a lot better. Alright, so we're going to condense some of these steps. Instead of accessing the local time class 3 separate times, let's just do it once. We'll create a local time object named now equals access the class of local time. Call the now method. When we assign hours, we will access our object of now. Now is our local time. Now.getHour. For minutes, now.getMinute. And seconds, now.getSecond. And then we'll insert them using our printf statement. Or even instead of assigning variables, we could just call now.getHour, now.getMinute, and now.getSecond. And we can delete these variables because we don't need them. Just for readability, I'll place these on a new line. And I'm just going to line them up. Alright, this should work too. Let's make sure. Yes, it does. You can keep this code the way it was before, but I like it a little more concise. Alright, our while loop is done. So, once we escape the while loop, that means the local time is our alarm time, or past our alarm time. So, for testing purposes, let's output the following. Let's just say alarm noises. We haven't added any audio yet. For my alarm time, I'm just going to set it to be 1 minute past what it is currently. In this case, 7:44. But pick a different time depending on what time it is for you currently. So I just need to wait for 20 seconds. Alright, once we reach our alarm time, or it's past our alarm time, we display alarm noises, and then exit the program. I'm going to add a new line character, just before we display alarm noises. For our alarm, we'll be playing some music later. Just for now, we're going to play a single beep, just to be sure that everything is working. Basically, to have Java make a beep noise, you can do the following. Access the class of toolkit, call the get default toolkit method, call the beep method, and then we do need to import this class. Once we escape the while loop, we will display alarm noises and make a beep sound, a single beep. I will set my alarm to be 7:47. I'll have to come back in 1 minute. There we go. We display our text of alarm noises, and hopefully you heard that beep. So we know that our alarm clock is working. To make a more sophisticated version, we're going to play an audio file. I have an audio file here. It's a WAV file. The following code isn't going to be compatible with MP3s. If you do have an MP3 file, you can always use an online MP3 to WAV converter. That's what I did. To make this convenient for me, I'm going to place this WAV file within my project folder. Here's my WAV file. Going back to our main Java file, I will create a string variable of filePath. String filePath equals, here I can list a relative file path or an absolute file path. This WAV file is within my project folder. I just need to list the file name. So I'm going to copy path, file name, and paste it within that string. With our alarm clock, we're going to send it our file path. We'll send it as the second argument, along with the alarm time. But we have to set up the constructor so that we can accept it. With our alarm clock class, we will create a private final string of file path. Then we'll have to set up the parameters. We are also accepting a string of file path, the location to that file, to play the audio. This .file path equals the file path that we receive. With playing audio, there's a lot of code we have to write. I'll dedicate an entire method just to playing audio. Let's make this a private method so only our alarm clock can access it. It's not going to return anything. The return type is void. Let's name this method playSound. Once we reach the end, we will call the playSound method. But we're going to pass in our file path. So we need a parameter setup of string file path. And now we are within the playSound method. To play a WAV file, we're going to create a file object named audio file equals a new file, and then pass in our file path. Import this class. We'll be doing a lot of importing as we go along. Then we need to create an audio input stream. Audio input stream. We'll name this audio stream equals access the class of audio system. Call the get audio input stream method. Yes, that's a lot to type. Then we will pass in our audio file. Import this class. Import the class for audio system 2. There's a lot of different exceptions that we'll need to catch, such as if our audio file is unsupported, like it's an MP3 file. We'll need some try and catch blocks. Try this code, catch any exceptions. Here's one we'll start with. We will catch any unsupported audio file exceptions, which we will name E. Import this class. If we encounter this exception, we'll output the following. Audio file format is not supported. If the audio is unavailable for some reason, let's say another resource is accessing it, we can catch that too. That exception is a line unavailable exception. Line unavailable exception of E. Let's say something like audio is unavailable. Import the class. Then, as a safety net, we will catch any I/O exceptions, input-output exceptions. I/O exception E. Here we'll just say error reading audio file. It is good to catch specific kinds of exceptions first, which we are doing. This just acts as a safety net. So with modern Java, you can try with resources. You'll automatically close those resources when you're done with them. When we create our audio input stream, let's cut all this code and paste it within the try with resources block, then delete that semicolon. So we have our audio stream. We need to create a clip object. A clip acts as a player that plays an audio stream. Within the try block, we will create a clip object. Clip equals access the class of audio system. Call the get clip method to create a clip object. Import this class. Then we will use our clip and open our audio stream object. To get the clip to play, we will call the start method of our clip. clip.start method. One issue we're probably going to run into is that once we start playing the clip, the program is going to end immediately, so we might not even hear it. So temporarily, I'm just going to sleep for a couple seconds. Let's just sleep for 5 seconds. And then I do need to add a catch clause for any interrupted exceptions. We'll be deleting this, don't worry. I just want to be sure that it works. I'm going to set it for 8:02. I got about 40 seconds. We played our music for 5 seconds, and then we exit the program. What I would like to do instead is that we stop the alarm if we hit enter. Here's how we can set that up. We can delete this method where we sleep for 5 seconds. Instead, we'll wait for a user to hit enter. And delete that catch statement too. We're going to be using a scanner. Within a big project, different parts of your project may require different scanners, but I like to just reuse the same one. The problem with having multiple scanners is if they use System.in and one scanner closes it, it's going to close System.in for all of them. So rather than close the scanner at the end of our main Java file, we're going to do that within the alarm clock class, when everything is all done. So we'll do that at the end of the try block. However, our alarm clock class has no idea what the scanner is. We're going to send it as an argument to the alarm clock class. So we'll need to set that up. We will pass in our scanner and reuse it within the alarm clock class. Within the alarm clock class, we will create a private final scanner object, which we will name scanner. Import this class. Set up the parameters. We will receive a scanner object that we can use throughout the alarm clock class. This .scanner equals the scanner that we receive. Alright, and now we have access to that same scanner, the same one that we have instantiated at the beginning of our program. And remember, we are not closing it at the end of the main Java file anymore. Once our alarm is playing, we will wait for some user input. Let's create a prompt. We'll say, press enter to stop the alarm. I'm going to use print. We will use our scanner called the nextLine method. Our music is going to continue playing until we hit enter. Once the user hits enter, we are going to take our clip and call the stop method. Then close the scanner when we're done with it. And that should be everything. Let's run this one last time. I will set my alarm to be 8:07. To get our alarm to stop, we just have to press enter. And the alarm stops, and we exit the program. Alright everybody, that is a working alarm clock that you can write using Java.